Hello everyone. Right now let's solve a question about conservation of moment. An astronaut of mass 90 kg carries an empty oxygen tank of mass 12 kg. By pushing the tank away with a speed of 3 meters per second, the astronaut recoils in the opposite direction. Okay, right now let's visualize that first. Okay, there's an astronaut here and there's a tank here. So in the space you cannot go anywhere, you cannot swim or something like that. But if you push something away according to the conservation of momentum, you can go in the opposite direction. Okay, so right now let's complete the momentum conservation diagram. Here we have the object is astronaut. Let's write down here astronaut. The mass of it is 90 kilogram, and the velocity of it is not given. We are going to assume that both tank and astronaut has a velocity of 0. Okay, the second object is tank, and tank has a mass of 12 kilogram, and the velocity of it is 0. Again, the same mass and same object. I'm going to just put here astronaut, and the mass of it is 90, and the velocity of it is question mark. We don't know it. The second object is tank, and 10 T, mass of it is 12 kilogram, and the velocity of it is, let's say it goes this direction with a 3 meter per second velocity, then the person need to go opposite direction. So we will figure out that our answer should our answer get negative or positive. Think about that for now. 3 meter per second. We are done with the momentum conservation diagram. Okay, right now let's write the equation of it. The general equation for the conservation of momentum is this. Momentum initial. I can write the most general. Momentum initial, impulse, and momentum final. Okay, so there is no impulse, the forces are internal. That's why eventually we'll use this one. Momentum initial equals momentum final. Okay, now let's write what we know, general equation. So we can put momentum before the collision is, I'm going to write down mass of, I'm going to put A here. You can put 90, or you can label it however you want. Okay, since they both have a different names, A and T and stuff, I'm going to just put like that. Velocity of the mass of the astronaut times velocity of the astronaut initial plus mass of tank times velocity of the tank initial. And mass of astronaut times velocity of the astronaut final, and mass of tank times velocity of the tank final. That is the equation that I am going to use. This is the momentum conservation equation. Now the question says that find the speed of the astronaut moves off into space. Okay, so the question is step by step helping me to understand that. So here, this is the equation, is already figured it out. Now what I'm going to do is I'm going to just plug the numbers. I can use the data here. Okay, so let's write it down. Let's plug everything here. Mass of the astronaut is 90 kilogram. And velocity of the astronaut initially is 0, plus mass of the tank is 12 kilogram, and velocity of the tank is 0. Mass of the astronaut is 90 kilogram. Velocity of the astronaut final, that is question mark. That is question mark. And mass of the tank is 12 kilogram. And velocity of the tank is 3 meters per second. Okay. Here, the left side of the equation is 0. Let's solve that. Left side of the equation is 0. Here we have 90 kilogram times the velocity of the astronaut final, plus here this is 36 kilogram meter per second. If you add negative 36 to the both sides, then you will end up negative 36 kilogram meter per second. Equals 90 kilogram times velocity of the astronaut final. Okay, let's divide both sides with 90 kilogram. 90 kilogram. Then we will end up velocity of astronaut final will be 2.5 meter per second, but it's going to be negative. So that negative sign tells us the velocity on the negative direction. Now I would like to go to the conservation of momentum diagram. Here, what we found is we found the 2.5 here. This is 2.5 meter per second. So if I want to complete the momentum conservation diagram, this is, by the way, is going to be negative. Okay. Here initially there is no momentum. Finally there is momentum. Let's say that if I do this one with 3 units, okay, if I do this one with 3 units, positive side, then this one will be 3 units, negative side. Okay, we can do it like that. So we are done with the question.